the thing that we sat down and we asked ourselves was, so how do we do this? Because a non-functional requirement, if you say the non-functional requirement, I'm just going to pick an example of I want page X to load and I want the front page to fully render in 5 seconds. I don't know, we'll just make that up as an example. So you could write a user story that says, as a user, I want the front page to load in 5 seconds or something like that, right? But if you're the developer and I hand you that user story and I say, go write the code for that, what are you going to do? You can write code, and you can write code that loads in 5 seconds, but I don't know that it's always going to load in 5 seconds. I know that it does maybe the day you write that code. I didn't actually give you a requirement to write the front page. I gave you a requirement to say that it loads in 5 seconds. So how are you going to take that and turn that into something that's useful to you? So what we talk about is what the thought that we have, and this comes a little bit out of some of the resources that I'll mention at the end, is instead of writing a non-functional requirement as something to do, make the user story be a test that validates the non-functional requirement. So instead of saying the requirement is the front page needs to load in 5 seconds, make the user story say something like, and I'll show you an example of this later, as a developer, I need to know if I change the code that the front page still loads in 5 seconds. And so then you can write a test that can run, load that front page, see if it loads in 5 seconds, throw an error if it doesn't, your test can fail and you can go do whatever you have to do to fix it. By doing that, you can then prioritize these stories in the backlog, because now you've got work that's boundable, that's repeatable, that you can give to someone to do that they'll understand, that's of the scope and the nature of doing a small user story in an Agile program. And you can prioritize these things so that they get done early as well. So now if I write a test that validates a non-functional requirement, and that test goes into our CI pipeline, so now every time someone checks in code, the first thing that happens is that my test runs and we see, yes, in fact, that front page does render in 5 seconds, or no, it doesn't. Then every time someone messes around with the system, they can know whether or not they've somehow adversely affected that load time. So even though you wrote that test and you're now out of the picture going doing something else, whatever it is you're doing, when you come along and you change some other part of the system and suddenly that test fails, you know that you did something that broke that test and you can go deal with it. And by prioritizing these things, you can get them automated and executing early on in your process so that you get that feedback back to the developer right away, because there's nothing worse than going to a developer 6 months from now and saying, by the way, that thing that you did 6 months ago, it doesn't work anymore, and then go figure out what's wrong with it and deal with it. I mean, that's not a context switch. I'm not quite sure what to call that, because that's way worse than a context switch. That's a life moment or something in terms of how much it takes to get yourself back into the frame of mind to understand what you were doing 6 months ago, really understand it well enough to figure out what was happening. And then make sure that your definition of done for whatever level you're looking at requires that those tests be run. Don't let yourself get behind the game. David and I work together, in case you don't know, but we talk about this stuff a lot, and I will, one of my either faults or strengths, or I'm not sure what it is I tend to speak in absolutes. I don't really mean absolutes in the sense that there's always a business justification for everything one does, right? So if a test fails, you could decide to take the debt and deal with it later. I'm not suggesting that you can't do that. But what I am suggesting is that you want to be done. You want to be done as quickly as possible. You want to get whatever it is you're doing completely done, out of the way, put it on the shelf, and go on to the next thing. That's what agility is all about, right? It's getting small units of work, getting them completed, getting them completely done, and being able to not go back.
Putting it on the shelf, you mean?
Shipping it, by deploying it. Yeah, the shelf is the deployment shelf, yes. Thank you for the prompt.
In the old days, software on the shelf used to be things that...
That's right.
You buy software and it just keeps sitting on the shelf, right?
That's right. Well, I'm an old guy, so that works out well. So what I wanted to do is try writing a few user stories and see if I can make you guys talk, first of all, and try to think a little bit about what these are. And I have a couple of examples here, but I'd even be happy to talk about something that you guys have run into that you think might be interesting, because I think these are when you start getting in, oh, I could get rid of that too. When you start getting into these user stories, some of them are pretty tricky, I think, and some of them are really hard to know how you're going to handle them in a way that's fast and repeatable and maybe even automatable. So let's just take an example and see. So this one I've talked about a little bit, right? So I wrote a non-functional requirement that says the front page must render in 5 seconds or less. And I don't think you can hand that to somebody and tell them to go make that happen. I understand that you sort of can, but in reality, I don't think you can do that in such a way that when they're done, they know they're done and they're always done forever. Whereas writing a front page that takes a username and a password and logs somebody in is something where you can know that you did it, you can test it, you can verify that that happened. So the suggestion is convert this into a story that delivers a test. So the story might be, and I don't profess to be a great user story writer, so if you want to argue with me about this story, you would have very little argument back. I don't claim that this is very good necessarily, but as a developer, I need to know that if I change the code, that the page still loads in 5 seconds. So that's a sort of a one way of looking at a user story. And now I have something I can go do. Because what I can do is I can define some acceptance criteria around this that deliver a test that will tell you whether or not that page loads in 5 seconds or not. So I decided to use given when then as a model for defining the acceptance criteria because it seemed like a good thing to do. And so I wrote for this one, I said, well, given that we have new code deployed in a production quality environment, because of course that 5 seconds isn't very interesting if it's in a little isolated environment that isn't at scale. So in a production quality scale environment, if I have new code that's deployed, when I try to hit that front page, does it render in 5 seconds or not? It's pretty easy to write a test for this, right? Anybody who knows anything about doing testing for a UI can write a test for this probably in a very small, this is a half-point story or something like that, right? This is not a big deal. But if I write this story, I put it in the pipeline, it runs every time anybody changes any code. When the back-end developer goes and introduces this heavily inefficient search that runs every time you load the front page, they'll know that immediately, and then that can be the signal that they need to go off and do something about this story. And then just as a couple of questions, we've talked about this already in this case, but is it automatable? Yeah, this one is definitely automatable. And what's the appropriate frequency? In my mind, every single time someone checks something in for this one's an easy one to do this way, right? It could be that there's others, as we talked before, that are different. So let's try a different one and see what happens. So we talked about this one a little bit too, but I didn't go as far into it. So the source code must not contain any software where the license terms are not met, or that we don't want to meet them, might be another way to say that. So can someone suggest a user story that might?
Similar to the previous one, anytime the new code is added, I think you have this black duck.
Right.
So it passes the black duck test.
Right. Okay, so I put in an as a, right? So as the compliance officer, with GE we have someone called a compliance officer, but your company will have somebody like that role. So in that role, I need to know that the source code of the software we are delivering does not contain any unlicensed software. Similar, right? But yeah, exactly. So what's the acceptance criteria? So it's pretty similar. So kind of back to what you said, given new code in the configuration management system, when the license scanning tools are run, there's no unlicensed software. Right? Now, is this automatable? Probably. It's a tool, right?
Yeah.
So it's a program that you run, so it's probably automatable. What's the appropriate frequency? Are you guys familiar at all with Black Duck or Palamida or something? There's another one like that. I can't remember what it's called. Yeah.
I would say we can.
So ideally that would be the case. It turns out that it's not a real fast thing to do. So you might have to do it less frequently than that. So now we get into some interesting, it's just a reality that it's not, if you're running it over. So one of the things that I don't know yet is how configurable is the tool and how much can you target just the changed code for that check-in. In that case, absolutely. Right, and these are some things I don't really know yet. If you had to scan your code base, for example, soup to nuts, then you might say, well, geez, that's a little, that probably can't be done on a check-in basis. But if you can just simply scan the delta and say, is there anything in this delta, then you might be able to do that, right? So one of the reasons I bring that up is today, currently, we don't run the scan on every check-in. We run it when we want to run it. And so the important thing about that is that now you have this problem that you have this repetitive event that has to occur. And you have to figure out how you're going to deal with that repetitive event, because unless you want to do something kind of weird like reintroducing user stories all the time that have somebody go off and run this test, you're in this weird mode where you've got work to do that isn't in your backlog, but it's work you need to do. So I'm not necessarily suggesting how to solve that problem, but you got to make sure you do solve that problem, right? So maybe you have a test strategy, and the test strategy gives you some structure for how you're going to do these kinds of things and when you're going to do these kinds of things. But you got to have some way to know. My goal here is to make this work transparent, because frequently these things are not as transparent as they should be. And to figure out exactly how you're going to get that stuff run on a periodic basis. It's kind of like manual regression, right? If you have a manual regression suite that you have to do, you've got to plan it, you've got to have the people available, you've got to do it at the right time when the code is stable enough, you've got to pick the right build and all that kind of stuff. And those are words that David hates, because the code is always stable enough to run regression tests on, right? Always. In your shop it is, yeah, exactly. So from that point of view, I think you have to say, well, as long as we have a mechanism for that, it's fine. Again, you may well be right. We may be able to automate that to the point that it can run on every check-in and it's no big deal. So.
Can I agree with you? I mean, it really depends on what the
Yeah, it does. And you just have to figure that out, right? Yeah. Yeah, we haven't, historically, we've tended to run it once late, which we're trying to change that. We're trying to get it, we tend to run it once late. So late in the process, like before we're about to release it. And
Just to put a word on defense, right now we run it on the cron, so next to run it like daily.
yeah. Yeah, and that's another way to solve the problem. You have a cron job, that job runs, and as long as somebody makes sure it runs, because sometimes those things tend to go into Neverland for some reason, but assuming that people are knowing it's running and that you're getting results and the real results are okay, then I think you're good, right?
I recall when I worked on the product development side, we used to run every build,
Uh-huh.
some of these things.
Yeah.
And just kind of take
Right.
the changes that have been tested and then trying to
Right.
pull them out, validate them.
Right. And again, it's the same thing, right? You don't want to get too far away from when someone made the change, because if you do, then you have the difficult problem of going back and dealing with that. And so it's the same kind of thing.
Yeah, we can talk about more about that as well, the next run, but that's
Yeah, it's a specific question. But so now I have one that I haven't talked about yet. And so we can spend a little bit of time on this. So this is a non-functional requirement. The software has to be maintainable, right? So you write the code, but she's got to be able to fix it when she finds your bugs, right? When somebody finds your bugs. And how do you know, this is definitely a requirement. It's not functional. You can't write code that makes it maintainable. That doesn't work. You have to write maintainable code. So how do you take this and turn it into something that you can actually go develop tests, and I'm using the word test very loosely here because it's not exactly testing, that can help you understand whether or not you have maintainable code on a consistent, regular, continuous basis? That's the question that comes up here. This is a real problem, right? I just heard about, and I've heard about code all the time where people look at it and go, oh, I can't believe the person did X, Y, or Z, right? So how do you stop that? Or how do you at least control that a little bit? Again, there's always business choices to make, but how do you make your code maintainable? So as a developer, I need to know if the software I write is maintainable. Pretty nondescript user story, right? But
It's very open-ended though, right?
it's very open-ended.
Because
So
it
what?
has cost of ownership, it has a lot of stuff in
Uh-huh.
it.
So what it gets down to is, what are you willing to accept as your acceptance criteria to tell you whether or not you think that code is maintainable? And the door's wide open. You can pick anything you want to pick, right?
Yeah.
I picked a couple of things here just as an answer. But what? So someone, you said static code analysis, right? So static code analysis is one way to look at some software and try to make a decision about maintainability.
Which static code analysis?
Well, it depends on the language, but yeah, so there are usually tools that will tell you Python, PyLint, or Perl Critic will say, no, you shouldn't be doing this. This is going to lead to bad code and stuff like
Yeah,
that.
that's definitely one thing. What's something else you could do?
All the code has to have like that.
Okay,
Every
okay,
thing that is changed.
okay.
That's a
What else?
amount of comments. Every module should have a owner.
Okay.
No memory leak.
So some of these I think we're bordering on operational quality versus maintainability, right? So I'm really worried about, you go into the CN Git or whatever, and you've been given a bug to go fix, and you look at the code and it's full of go-tos, right? And you're like, what am I going to do now, right? I can't possibly read this code, right? That's the question I really want to answer here is, how do you know that the code, that some person who's not familiar with the code can, with relative ease, step into that code and confidently make a change to it that they know they aren't going to?
So one way is every code has to be, let's say, code review.
Okay.
By one cross-team or something like that.
Uh-huh. Code review's a good way to do that.
So that's kind of getting.
Yep. Yep. Anything else?
I've written books about this.
Yeah, I know. There's a bunch of things. So you're right. It's a very complicated subject.
Yeah.
My point here is that if this is important to you, if this is a non-functional requirement that you think you should have in your product, then you need to decide what it means, right? Because if you tell, if I'm standing up here as your leader and you're my software team and I say, write maintainable code, and I turn around and leave, what does that mean? Okay, I mean, it can be as simple as every person has a different number of spaces that they indent. And that can be infuriating in code, right? Especially when you've indented everything 4 spaces and you come in to change the code and you like 6. So you start doing things at 6 and before you know it, you can't read anything, right? And it's all about indentation. So, maybe you have a coding standard. And part of a code review might be to verify whether or not you're meeting the coding standard. You can also do that with tools, right?
You can actually reformat it as part of the check-in process.
You can.
It's all,
Mhm.
And then people won't waste their time trying to add other spaces.
Or replace tabs with spaces and all those kinds of things, right? Yeah.
So there is a tool to do that?
Oh, yeah. Yeah, you can to some degree implement a coding standard in tools. Not completely, but to some degree you can.
Writing it, as soon as you say it, they can island here. You can go to your code and
So I picked a couple of things up here. And the first one I picked was a complexity metric. And I just said, you know what, we're going to take all of our code, and we can automate this largely, and say we're going to run a complexity metric on our code. And if it's less than 10, we're going to say it's maintainable from a complexity metric point of view, which if you read about these metrics, that's kind of what they say. There's controversy around complexity metrics. I'm not trying to say it's the best answer or not. I just picked it as an example. But there is always the possibility that there's something that just, it's complicated. And there isn't a great way to satisfy the complexity metric the way the code needs to be written. So you might want to have something like the or, which is, or my senior architect guy here says, even though it's complicated, it's the right way to write the code, we're going to leave it that way. Because you might need to have an exception process in the case that.
Is that a real tool, Machiavelli?
It's a metric. There are tools that will compute that metric. So yeah, there's a bunch of tools that will compute that metric and tell you, and it looks at, if you go look up this metric, there's a whole description of the algorithm it uses. It has to do with ifs and nests and things, and I don't know, I read it and immediately flushed it. I didn't get the details of it, but it's a way of measuring it. There are people who believe in it, there are people who don't believe in it. I'm not standing here saying it's absolutely the right answer.
You have the waiver for
Well, it's partly why you have the waiver, because it may be that you need the waiver, right? The waiver was a David Vidra add-in, and I think a good one, right? So, and then the other one you mentioned, which is everything needs to have a review, right? You need a second set of eyes on all the code. And this doesn't say it has to be a formal review in a meeting room with 6 people playing roles, or, you know, hey, come over here and take a quick look at this and see what you think of it. It doesn't, the point isn't how you do the review, it's just that there's a second set of eyes on it. If we pair program it, maybe that's good enough as a second set of eyes, right? But you might want to decide that somehow in your process, there's a way to know whether or not there's been a second set of eyes on this code.
This is the second acceptance criteria is more like an operational thing. So does it really belong in a story?
Well, what I might do with this is I might put some hooks in Git that don't allow you to put it to, so maybe I have to issue a pull request, and maybe I can't also do the pull. so that in my process, if I do a pull request, I'm not allowed to actually go turn around and be on the other side of it and actually do the pull. So that somebody else has to do that, and you can call that review. Is it good enough for you? Depends on your system, it depends on your company, it depends on your people. But you could tell people, you know, if you look at open source, right? I can go fork a repo someplace, I can make changes to Linux, and I can issue a pull request. Well, you can bet that they're not going to just go, oh, Don issued a pull request, I'm going to take his code, right? They're going to go look at it and say, what did Don do? If they even look at it, because they don't know who I am. But you know, the same thing should be true. Whoever is on the other side of that pull should feel an ownership to putting good code into the code base. And while like if David wrote the code, I may think he's a very good developer, but that doesn't absolve me from taking a look at it and saying, you know, I think he really did a good job with this, or not, right? So I think you can solve non-functional requirements in many, my point here is that there's many different ways to solve non-functional requirements. That's not really a test. It's kind of a test in the sense that David submitted the code and I'm verifying it and I'm going to give him a thumbs up or a thumbs down on it. But it's not computerized. It's me, it's people oriented, but it's just part of the way, it's part of the workflow, and it's the way we do work. So it's just another way to solve a non-functional requirement. Yes?
So to me this is more like an engineering practice.
Mm-hmm.
So do company really put those as
So I'll give you $1 later for leading into my next couple of slides. But yes, it's a good question. It's a good question. But I think that there is business value in this story, right? You know, if you write a bunch of code and then for whatever reason you decide to leave, you might be able to maintain it because you wrote it and you know what it does. But when you leave and suddenly I ask you to deal with it, can you deal with it? How much time do you have to spend looking at it? I'd like it to be less than more if I'm running the company.
the reason I asked that, say for example, my team is Scrum.
Uh-huh.
Will I write a story, say, as a developer, I need to participate in the daily Scrum?
No.
Will I even go
No,
that
this is about, these are requirements on the product. Okay, so I'm not talking about your process. But what I am saying is that if there is a requirement on the product that can be satisfied by the process, you can do that. So I'm not saying you should write stories around how to do, I mean, at some point you'd get circular and you'd get lost, right? You know, it wouldn't work. But my point is that with regard to what it is you're developing, if there's a reason to do this story, one of the ways to solve the problem might be to make sure that your process does it. That's all I'm saying.
Make a comment. These look like requirements on the tooling, which is another kind of a product. It's an internal product, right? You can see it says basically you have to do this thing in the case you have to set up the tooling to run compute complexity metrics, right? Then you run it all the time. So it's kind of, I agree, it's a little bit of a thing, but you know, I think it's important. idea behind, modern Agile is people recommend we have a single backlog. Even like a bot tracking system, I forgot the name of it myself, but according to Europe, it's the hidden backlog. Right? If you really want one stream of work, and if you neglect something, right, you're gonna pay the price. You really need all those things. You need to make decisions to work, what you're gonna work on.
When I wrote the non-functional requirement using waterfall or rapid methodologies, I just felt like some of them are redundant. Like one is maintainable, then the system has to be scalable.
Mhm.
So I felt like some of those non-functionals are redundant. So, maybe in Agile we don't need to address all of these. Address like the previous one I thought was really good. So that's what this is my feedback.
So I'm not suggesting that there are requirements that you should or shouldn't have. I think that's a business decision based on the product that you're developing, right? If you think it's important that code is maintainable enough that you're willing to do this, then great, you should do that. If you're not worried about maintainability for some reason, like let me give you an example. If you're a consulting agency and you're going to write some code and it's going to go run, it's just going to sit there and it's going to run forever, you may not care about maintainability. You may not want to waste your time dealing with a bunch of overhead around maintainability. If you're developing a product that you expect to live for 10 or 20 years, maintainability might be really, really important to you. Because over 10 or 20 years, you're going to have turnover in your company like crazy in terms of who's working on the code. You might really think it's important that that code be maintainable. So it's all about what's important to you. Again, I'm not trying to tell you this requirement is an important requirement. I picked it because it's one we are happening to look at right now as well. So that's one of the reasons I put this on the slide, because we think it's important to have maintainable code, enough so that we want to talk about requirements like this with acceptance criteria like that.
I think we are hearing visible for the developer, visible for management, everybody, that this is the...
That's right.
So it's
Yeah, everybody, the whole team.
So user story is a way, but actually there is no direct customer.
Well,
Yes.
it's direct or it's not, right? I mean, if it takes me a week to fix a bug versus a day to fix a bug, and this is an influence on that, there's a direct customer impact to that. How easy it is to prove that that's the case, a different question, right? But
this user story is focused around
yeah.
products often must be maintained. Not just me as a developer of that product or as a product company, but also when I deliver that product to a customer. How much effort they're putting in maintainability of that product.
How many of you have worked on a system where there's a module someplace and you look at that module and you say, oh, we only want Joe to touch that module. That module is scary, and I don't want anybody but Joe to touch that module. I've certainly worked in that world before. Or don't change this one because it's so convoluted that we're afraid that we don't know what the side effect of changing it's going to be. That's another one that I've heard multiple times, right? So now you have, yeah, exactly, yeah, the old job security thing. I've written this code to be so obscure that I have my job for life, right? If that's what you want, or if that's what you're going to end up with, that's one choice. But what this does also is it tries to avoid problems like that.
In
Right.
Agile, we just ask you to create a story. I need job security.
Yeah. As a developer, I want job security so that I can, yeah, that's right. Yeah. So again, we're going to talk a little bit more about selecting requirements here, because I think now that we've done this a little bit, we can turn our minds a little bit towards selection of requirements and see what we can do. Oh, so this one, is it automatable? Maybe. Depends on what you do. Even this one isn't fully automatable in the sense that you have this OR thing, right? But it's certainly automatable as long as people write code that's 10 or less in complexity, right? You might argue it's automatic in the sense it's how people work. And so therefore there's not extra stuff you have to do because it's just how people work, but it's not software that's running. It's people doing their job.
Well, you have to configure like Jenkins and GitHub.
Oh yeah, you're right, there's tooling that will facilitate this, but it's not automatic in the sense that when I click, commit, or push, or pull, or whatever I click, right, that it just all happens. That there is involvement by human beings in this process. In that sense, it's not automatable.
It's semi-automatic.
Yeah,
But as long as it's 10, the whole thing can go forward automatically.
yeah, as long as this is not also another acceptance. I mean, if both of these are required, if you say, well, if it's 10 or less, I don't need a code review. Well, 10 or less code could be, you could write code that's a 3 in complexity and use the variables A, B, C, D, and E, right? So is that maintainable? It's not complex, but it's not maintainable either, right? So would you be willing to accept this as the only criteria? Maybe, maybe not, right?
I just wanted to share one story. So at Google, every new engineer had to go through code readability review. And the way they enforced it is you could not check in code until you passed the code readability review. So you made you write some code, then you have to go before a committee. And they didn't care if you had a PhD from Stanford, like half of them had PhDs from Stanford, right? Because they really cared about maintainability, because they thought that Google was going to be around for a while. And so everybody had to do it, no matter how, what's your background. And you have to do it for each language. So you may be good at Java, but they ask you to write some JavaScript. You cannot check in your JavaScript. You should go through that thing. Or you have to get somebody who's certified for JavaScript to review your code. No way to check it in. You don't have the keys.
So that's only for the first time?
Until you pass it.
Yeah, you have to be certified for each language. But the certification basically, it's not like you pass it. It's not multiple choice tests. You have to write 100 lines of code. You go before a committee. They tell you, okay, it's a good start, but here this, and that. You take another round, and they look at it and say, well, better, but now fix this and that. And then there's guidelines to read. I mean, they really force you to really take it very seriously.
So that's for the first project.
Yeah.
So then there is a next sprint. One has to go again the same thing?
No.
Once they think that you know how to write readable Java, they will.
They assume you're writing readable Java after that.
Very good.
But they
Yeah.
spend a lot of effort and money, but it created a culture where, because they move people around a lot, where you knew that part of your job was to write maintainable code. There was a lot of training about various principles of maintainable code, a lot of engineering training. So that companies that product companies, they put a lot of effort into it. So some do.
Yeah, I was coming from the point where this is really in general, nothing. I know we are learning how to write stories around an NFR. I was just coming from the point whether this is really a requirement or this is a discipline that the designer QA team should follow.
So-
on that point.
You can play both of them. Yeah.
You can, and I think it's important to recognize, though, that there can be a fine line between discipline and hidden work. And what we're trying to do is expose the work, not the discipline, but the work. So if you find yourself going off and doing things because of discipline, I wonder if that's really why you're doing them. Because if they're work that you need to do, it probably needs to be exposed. So if you step back and you say, well, one of the interesting things about Scrum that you do is you understand the velocity of the team, and you use that as a way to predict how well the team will perform going forward, right? Well, if you're doing 10 hours a week of undocumented work that's not showing up in any backlog, we don't really understand what the velocity of the team is. Because 25% of your time in a 40-hour week is undocumented. And yet, that undocumented work needs to be done. And so all of these non-functional tests, a lot of them end up not being documented in ways that are transparent as to what the work is. And so you end up with a problem of all this work that you need to do that nobody really realizes has to happen until it's too late. So that's what we're trying to talk about. We're not trying to enforce, this is not about enforcing discipline, it's not about enforcing process. It's about making sure that the work that needs to be accomplished is transparent. So for example, if this has to happen, people have to account for this in the work that they do. This is work, right? So you can't, if you just go, oh, wink, wink, nudge, nudge, they're going to get that done, right? Then you start having people working 60-hour weeks because they do their 40-hour week and then they spend the other 20 doing the pull requests that they have to do, right? That's not managing the capacity of your team the way that you should be managing the capacity of your team. Yeah. Okay. So you kind of led down this path here a little bit, which is who writes these stories, right? So we know for sure that functional requirements tend to come from the product owner, product manager, as you know, and they do that in conjunction with the team. Like, you know, the team might say, hey, here's a function that would be good to do, and you might decide to do that. There's some give and take that goes on between those people. But really the product owner and the team are developing the functional requirements for a product. When it comes to non-functional requirements, I think that there are multiple sources of these. Certainly, the product owner and the team play a role in this. The performance characteristics, certification. Let's say you have to go into a HIPAA environment or some financial environment that has security requirements. You know, those things all need to be defined as part of the product. That may be non-functional, but very important, critical to the success of the project. Maybe it's in a safety environment, right, where people could be injured if the software doesn't work well. Well, you need to make sure you account for that as part of your product. And that's all going to come from the product owner because they know who the customer is, they know how it's going to be deployed, they know who the users are, and they know those kinds of requirements. You might have a compliance organization that lays legal requirements on you, like licensing, for example, right? They may say, well, we're not willing to accept these certain types of open source licenses because of what they do to our code, like they might cause us to expose intellectual property or something like that. So we don't want to use these kinds of licenses. The product owner probably doesn't really care. I mean, they might care about that at some level, but it's more likely some legal organization in your company that's going to talk about that stuff. You might have UX usability requirements. These are really hard. I thought about doing an example of these, but you know, how do you do usability testing, and how do you know that somebody wrote usable code? It's a tough question, but you're going to have these kinds of requirements, and you're going to have to decide whether or not they're important to you. And then you have the engineering aspect of it. You know, is the code testable? Is it maintainable? Is it supportable? You know, whatever it is, the kinds of things that you want to build into your code so that you can keep it alive and it's usable for you in the long term, right? And this might come directly out of your own engineering organization. The product owner will care in the sense that they want a high quality product delivered, but they may or may not know how to specify these requirements. This may come directly out of the engineering organization. And there's others, right? There's a lot of these. These are examples. But, and I'll talk a little bit more about that in a second. You know, and again, to your question, the hard part is what do you care about? What's important? What delivers business value to you around your product? Because you could write, I mean, you could write 1,000 non-functional requirements around every project. You know, you could have a project that, you know, puts a hat on a cat, as we looked at in the video earlier, right? And you could write so many non-functional requirements around that thing that you'd never actually get a hat on a cat. And maybe all you really care about is that there's a hat on a cat. So coming up with the ones that are important. So the good thing about it is you define whatever you think is important to define, and then it's all about backlog prioritization, right? So now it's transparent. So now you know what they are. And now you can go to your product owner and say, hey, product owner, if you don't let us spend the time it takes to make our code maintainable, then you're going to end up with longer cycle times on defect fixes when the customer reports a defect. That's an outcome of that. So if you think this is important, you need to bump this up in your backlog so that we write the test or do whatever we need to do to make this happen, right? If you think it's important that this code is testable, then we need to make sure we're writing code that has the right hooks and the right capabilities so that we can go in and test it, whatever that means, right? You know, how important is it to you, product owner? If I have a UX designer, and the UX designer comes up with a whole look and feel and colors and whatever on a web page that you're going to develop, how important to you is how precise to their spec do you need to be? Is it important that you're to the pixel? Every color is exactly right. Every pixel's in exactly the right place. It scales and it sizes to resolutions and everything else. Or does it need to be pretty close? How exact does it need to be? Because it's going to really affect how you do usability testing and how you do UX testing. So these are all things that you just have to think about, and that's where your product owner will help you because they can help you prioritize this stuff. A good product owner will realize that some of these things are important, and they'll prioritize them high, and you'll actually get time to spend on them. You do a few of these things early on, you do the right ones early on, and you're setting yourself up to have a much smoother ride than if you wait until the end and try to do all this stuff later on.
Do you say in general technical have to be considered non-functional requirements?
No, I don't think non-functional requirements are technical debt. I think they're part of the backlog. If you, to me, technical debt is, how do you define this? Something you know you need to do, but you're deferring until later, right? So like somebody finds a bug, and you say, well, yeah, I know it's a bug, but right now there's more important things to do, so I'm not going to do that until later. I mean, at some level, by that definition, you could argue that everything in your backlog that you're not doing right now is technical debt. But I'm not sure you want to.
Well, I mean, you can also have a more precise definition that
Yeah.
that technical debt has to do with the internal quality of your software, right? So a lot of the modern software development approaches have agreed that really you don't do that much separate design outside of you code and design software at the same time, right? Code is the design. And so if you're not refactoring and you're not improving your design, right, that becomes technical debt because that really affects your maintainability, and then it could really impact the organization. People may leave, you may have to put hiring people, and so that you can track. And sometimes you have to kind of just work hard and ship something, but then you should plan to, and that goes in the backlog. Yeah, now we need 3 weeks to go and clean up the code and actually be visible, and you make these decisions.
Right. So one of the things that we talk about is deployable code every day. We want to be able to go all the way into production every day. And technical debt, in my mind, would be something that keeps us from doing that. It'd be choosing to do something or choosing not to do something that would break that rule, right? So the problem with some of these non-functional requirements and the way that organizations tend to treat them, you basically have continuous technical debt because you don't know if you can deploy because you haven't done your performance testing yet. You haven't done your license check yet. There's all these things you haven't done yet, and therefore you can't be confident that you can deploy and that your customers aren't going to scream. So in order to be able to do this stuff on a regular basis, it's a good term to talk about here, I think, because if you choose not to do it, I think it becomes debt. It's when you choose to do it that it's not. But I don't think it classifies as technical debt. I think it's how you choose to, it's what you choose to do with it that makes it technical debt or not. So if somebody says this is really, really important, but we're not going to do it right now, that becomes debt. If someone says it's not important, it's not debt. It's not important. Yeah, and so here we are, right, back at the, which one should we do again, right? And what we've found in our experience, and I think there are different places with different things of import, performance, scalability, protection of intellectual property, so making sure that if you're going to do a patent filing that you do it before you release your code, those kinds of things, right? License compliance, security, these are all things that you got to do something about. No one's going to let you out the door if you haven't got your security down. They shouldn't let you out the door if you haven't got your security down, right? You don't want to release code that contains GPL3 unless you want to open source your code, right? You don't want to release code that contains a proprietary license from somebody because you're going to be subject to potential lawsuits, right? So the licensing thing I think is really important as well. As just a funny side story, at a company I worked at a while back, we ran Black Duck on our code base and it flagged a piece of code and it said this is from the open source community. So we went and we looked at it and we found the code in the open source community and we traced it back and it had actually been stolen from us earlier than that. Ooh. So it was our code that someone had introduced into open source, and then we ended up picking up that package in something that we did, and then we got flagged because we were using our own code in open source. And we had proof because we had a configuration management system that had that code that was older than the open source package even exists. So it was anyway. So, those are the kinds of things you can run into that you got to look at it and you say, well, what does that mean? Because the license on that package might be something you don't want to agree with, but that was our code in the first place. So you got to have a legal opinion on that, right? You got to know how to handle that. So those are the kinds of things that can take a while to deal with. The sooner you know, the better off you are. We found that one late, and then we had to kind of pause and go say, well, how do we want to handle this? So that was a long, long time ago. The other thing is, and then we talked about this a little bit earlier, is this whole long-lived versus short-lived thing. A lot of these non-functional requirements tend to be important in a long-lived product more than in a short-lived, sort of like a custom one-off solution type of thing. So if you're working on a 10 or 20-year product, these things are really critical. You know, many of us might start working on a 10-year product and not even be at the company anymore 5 years from now. And yet someone's going to be there and someone's going to have to deal with that. And you know, as good citizens, we need to do the right thing here. And some of that is writing maintainable code. Just because you know you're not going to be there doesn't mean that doesn't absolve you from doing the right thing. And it really is the responsibility of this team to determine these. Now, it may be that some of them are dictated. Like the legal team may say, we will not let you release until you've done a license scan of your software. We will not let you do a release until we've done some sort of a security analysis of your software to make sure we can't break it in some way. But largely, these requirements are up to the team to prioritize along with the functional requirements. Because it's the same group of people who are doing the work. Their time is their time. They have time to write functional requirements and they have time to do non-functional requirements, and somehow you got to prioritize that stuff. Some of them I think are pretty easy, like that, you know, they'll load the front page in 5 seconds. That's a pretty easy thing to pull off. But some of these aren't. Some of these are a little trickier.
But I would challenge you.
You know, when I said that, I almost knew I shouldn't have.
So I want the page to load in 5 seconds in a certain city in India, for example.
Right, yeah, so you want to introduce,
Layers of net
yeah,
translation.
you want to introduce latency and all those kinds of things
So
too.
yeah,
Yeah,
so
that's
that'd
right.
be-
With a server in California and the client in, yeah, Timbuktu. Yeah,
Then we may have to go to Keynote or whoever does that fancy testing and spend a bunch of money. But
Yeah.
that may be a requirement. That's
yeah.
part of our
But
business.
but it's doable. I mean, it's not that hard to introduce latency in a test and say, okay, we're gonna, you know, we're gonna introduce 3 seconds of latency and your 5-second load isn't gonna work, but that's okay, right?
So there's all kinds of things.
Right. I made a list. I don't think I'm going to read all these because it's a list, but I made a list of some requirements that we've been looking at a lot and that might be helpful to you or anybody else on the kinds of things to look at. You know, yeah. I don't think I want to read them all. This last one I think is really interesting. We've had some interesting discussions about coverage testing at work. And we get into these discussions about how much should we cover, you know, how deep should we cover. And where we've landed is that's not what's important. It's important to write tests that cover your code, but what's really important is to know whether it's okay to not have tested what you didn't cover. That's the more valuable thing, is to say, if we wrote testing that covers 70% of our code, what about the other 30%? Someone should go look at that other 30% and say, it was okay not to cover that. Maybe it's a bunch of setters and getters and it's simple code and you don't have to worry about it. Or maybe it's the most complex business logic you had and you had a really hard time getting into that code from the automated testing that you had and you didn't cover it, but you really should have. And then you need to go back and say, what was wrong with that? So coverage is an interesting example of something to think about because I think that too often we get hung up on the numbers, right? It's what's a good percentage for code coverage? If I asked you all to write down a number on a piece of paper right now in secret and pass it around, we'd probably end up with, I don't know, 10 different numbers. How many people are there? 10 different people? We'd probably end up with 10 different numbers. And that isn't really what's important, I don't think. What's important is what didn't you cover? And is it okay not to cover that? You know, I worked in an environment in the past that delivered safety critical software to run an AV audit. And one of the rules was that we had to have every line of code had to be covered, or you had to write basically a paper on why you couldn't get there and prove to them that was okay. So no dead code. If the code was dead, you had to remove the code from the system. And not only did you have to cover it, but you had to do something called MCDC coverage. And I always get this messed up, but it's like multiple condition decision something. I forget what the last C, anyway. But basically every branch, you have to test all the possible outcomes of every single branch. It's amazingly deep coverage. But you have, you know, they talk about in that world, souls on board. You know, you got an airplane flying along with 350 people on it. You can't afford to have software that goes, oh, well, I don't feel like working right now, right? that doesn't fly, so to speak. So anyway, I put some more on another piece of paper, another page. Yeah, well, how about documentation? You know, not is the product documented, but is it documented such that a new user can come up to speed quickly? That's a really hard thing to figure out, right? But you might need to figure that out. Yeah, you know, to the extent possible. So those are all interesting things. This is a list. There is a much larger list on Wikipedia, if you want to go look at it, of areas for non-functional requirements. I just took these ones out because I thought they were ones that we cared more about than, it's not that we don't care about the others, it's just that it is a bit overwhelming when you start looking at this. There's a lot of possible non-functional requirements. You know, resilience. Resilience is really interesting, right? What happens to your system when you overload it? What does it do? Is it okay? Price. You know, write me software that doesn't cost too much to deploy. That's an interesting requirement. Think about the acceptance criteria for that. So there's a whole bunch of them, and I have a link at the end here to go through. So just to really quickly on automation, you know, we want tests to be automated. We want them to be part of the CI pipeline. We want them to run all the time whenever it's humanly possible. We want that feedback to get back to that developer as soon as they made a change, so to speak, right? So there are some tests that are automatable, but they take a long time, right? Like you might be able to automate a resilience test, but it has to run for 3 hours or 6 hours or something to give you the results. So then you can have these automated, you know, these like daily cron jobs or those kinds of things that or maybe it's a black duck scan or whatever, right? Something like that. And then of course there are some tests that are going to be manual. There are just some things you're going to have to do manually. And my only comment on that is make sure you have a way to know what's happening, to know that you're getting the right result, and that you do it when you need to do it. Because it's easy to lose track of that kind of stuff in the pressure of what's going on. It's not a user story per se in the backlog. Maybe it should be. Maybe you can make it one or not. Maybe you keep reintroducing a user story over and over again. I don't know what the right technique is to do that. But make the work transparent. When you have these manual tests, you need to know that some of the capacity of your team is going against these manual tests, and you want that to be just as visible as any other work that you're doing in the project. So kind of in conclusion, you know, we talked about functional requirements define the operation and the NFRs define the constraints. There are many sources of these non-functional requirements. They come from all over. It's up to the Scrum team to write those stories around those and then develop the tests that show that you've achieved those non-functional requirements. And it's up to the team to even decide which non-functional requirements are important, because it really can vary project to project. And then the last thing I have here is just a short bibliography. I went to Wikipedia. There's some non-functional requirement stuff there. Scaled Agile Framework talks about this a little bit, and Dean Leffingwell, who's is the founder, I guess, of Scaled Agile Framework, has a book, Agile Software Requirements, Lean Requirements, Practices for Teams, Programs, in the Enterprise. And chapter 17 of that book is devoted to non-functional requirements. So I use that in putting all this together. So, any other questions? Thank you.